Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Peace and blessings upon you all. Dear students, today we'll learn about this is actually the last missed out topic, basically. That is the project management technique, which is the last topic of your syllabus. If you see your syllabus, and there is basically the two techniques we'll be reading in it. One is the PERT and one is CPM. Okay, let's today give the thorough introduction of what is project management, so where we use the PERT, and what is CPM, and why we use these techniques in the project management. So first thing what we need to understand is what is a project. Okay, so it's an interrelated set of activities. Note down there are some interrelated set of activities that has some definite starting and ending point, and then you start the project. Okay, it has some steps to go through, and then you get the final product. Okay, and why we are reading this in our optimization technique is because we want to manage the project in such a manner that we will have the minimum time. Okay, because I told you in the optimization we always try to maximize or minimize something. Okay, so we need to complete the project in a minimum time, and we also need to minimize the capital investment. So you also need to minimize capital investment. So whatever you are investing, the investment can be in terms of money, it can be material, it can be manpower, and it can be a lot of other resources, and you have to schedule maybe these steps in such a manner, okay, that we minimize the time, we minimize the cost, the money, the material usage, the manpower, and other resources, right? So to manage these, how you manage these? No, in a scientific way, you plan, you implement, you monitor, and you control. These will be our steps of the project management, right? So in optimization, we just want to minimize the time, money, material, and everything what a project consists of, such that we get an efficient product at the end, which is not hogging up the resources too much, right? So in nutshell, we are saying our project, it is a combination of some interrelated activities. So this is activity 1, activity 2, activity 3, 4, some kind of activities. Okay, and you have to execute in them in such a sequence, you have to schedule them in such a manner so that you can accomplish the desired objective. So what is our objective? To minimize the cost and minimum capital investment, and etc. So that the resources used in our project are minimized. So that is the key, in that is to schedule these activities or steps of the project or different phases of the project in an efficient and optimized manner. So what we can say a project, what exactly is a project? For example, we are building new buildings. From the gate, from the right side, you can see a lot of buildings are getting built up. So say there are some supervisors, building supervisors, who are in charge of construction of these buildings. What is their main responsibility? They coordinate the work of various contractors. Some contractors are getting bricks, some are getting iron, some are getting concrete, and there are a lot of people working together, and they need to work. Somebody has to got material, somebody has to build it, somebody has to design it. There are a lot of things to be done. So a building supervisor, the supervisor who is there, he has a job on a hand, so that the buildings will be finished, the final product will be within the budget and on the time. So he has to optimize in a manner all those phases of the project, so that the buildings will be built on time and within the budget. Okay, so it's a very large project, right? So like we have the COVID vaccine here going on. Maybe the WHO is directing the research scientists to run trials on the COVID vaccines on behalf of the Pfizer company, the pharmaceutical company, and then build the vaccine for us. Okay, so that we can have an independent statistical analysis on it. So again, it's a project management. It's a big project, and we need a project management for it. Okay, same ways, for example, if someone is given me the role to design a new teaching techniques, and I am I am assigned the job, again it will be a complex formulation and I have to use the project management techniques. Okay, does it make sense? So either it could be the shopping complex, in fact it's not a shopping complex, it's a building. It could be the new vaccine, and it could be some new teaching techniques which I have to design, right? So overall we have to manage the project. It's a scientific way of planning. You have to plan first, then implement, then monitor, and then control various aspects of projects, just time, money, material, manpower, and other resources. So the project involves planning, scheduling, controlling, a number of interrelated activities, and we need to know that they are all interrelated, these activities. Okay, and we have to use the limited resources, which could be man, machine, material, money, time. And the projects can be extremely large and complex. Just say, like I told you, the building, we have to make the buildings for Islamic college, we have to build highways, we have to build shopping complexes, we got flyovers. There could be a lot of things, like we have the flyover going from up to Natipura and airport, and you see how much time it took, and there's a lot of things going on, so we have to manage it such that it finishes within the timeline. Okay, you could have a new products, research and development projects. For example, there's a new vaccine coming up, so these are all the projects, so we need to manage them. So we need to have the managers which are having the dynamic planning and scheduling system in place to produce the best possible result. Okay, and if there are some changing conditions, for example, our flyover, there were no strikes and all, there is a disputed scenario in the Kashmir, and we see the flyover is not getting finished. We usually say the dialogue, hey man, it's our, maybe the kids who will see this flyover, not we. So because there is the possibility of changing conditions, and accordingly we have to adjust, and we have to change the plan and schedule, and it has to be very robust, and only then we can finish our project on time, and that too within the budget. Now when we try to solve and optimize the project management issues, we have what's called the network analysis, which refers to a number of techniques for planning and controlling of complex projects. And we have a couple of techniques here, which is also called the form of network planning or project management. First is the critical, in our syllabus, is the first is the critical path method, CPM, and second is the programming, evaluation, and review techniques, what's called a PERT. So we will be actually reading first this and second this. So firstly, what is a network? Network is simply, where we have some nodes and there are some arrows which tell us which step is we're gonna do after which step, right? So this is a logical sequence or scheduling of the steps or phases, or what we have here is the node. Okay, so there are some nodes and there are some arrows which are actually the path, which gives us the path, and this is called a network. Now you have the activities and how you concentrate your resources that to effectively on particular activity to speed up the project completion. Now then you have a budget, and you have to spend, your you have to show the expenditure you have on the activities, how much expenditure you will do on each and every activity, so that the overall project stays within the budget. So these are some questions which need to be answered when you try to solve the project management issues. And for that we have the two techniques of the PERT and CPM, that is program evaluation review technique and critical path method. These actually provide answers to all of these questions. Okay, all of these questions, the PERT and CPM is gonna answer the questions, answer these all of these questions. So now let us talk about the actual thing, that's the PERT and CPM. It was developed by the US Navy for planning and controlling a polar missile program, and they used actually the PERT. And the CPM was developed by DuPont to solve project scheduling problems. They are, around about same time, two set of people try to do the things. One did the PERT, other did the CPM. Now here, in the PERT, more emphasis was on you had to complete the program, the project in the shortest possible time. You need to minimize the time, finishing time of the completion time of the project. But here we were thinking about the trade-offs between the cost of the project and overall completion. Sometimes if you have a lesser cost, you can take up more time. But if you increase the cost, for example, then you can have a lesser time. So there's a trade-off between the two. So what is the optimal, which will be best in terms of cost and also in terms of time? That is what CPM was used to solve the thing. So we use the PERT or CPM to predict the deliverables, planning resource requirements, controlling resource allocation, internal program review, external program review, performance evaluation, uniform wide acceptance, and all of these led to the project management. And these are the examples of the applications of PERT and CPM techniques where we use PERT and CPM. And these are the steps which are used in the PERT and CPM. First is the planning. This is the project management, the steps of project management you can see, or sometimes it's called as an elements of project management also, where we plan first, then we schedule about the schedule the activities or the steps which belong to that project. Then we want to allocate the resources to that, to those activities, and then we need a controlling. And overall, we'll get a project which is finished, taking minimum resources and in optimized time. Okay. Now, when you are trying to use the PERT and CPM, you need a clear idea about the project firstly. So the project should have only a single start activity and single finish activity. There should not be a confusion that where the project starts and then there will be a lot of sub steps which are interrelated to each other. Then there should be a final step or activity where it finishes. So we need to have a clear idea of where the project starts and where it finishes. So these are some constraints we need to take care of. And then there are some relationship between these sub steps and activities. Okay, so because we need to schedule them in a sense, in a scenario which will minimize the waiting time, which will minimize the resource allocations, and which makes speed up the project. So we have to have understand what is the relationship between these projects. So for example, this is one activity, another activity. This activity depends on this activity. So if I try to go on first this activity, which can be only done when this activity is finished, so I have to wait. So it only makes our project more lengthy. So we have to schedule in a sense which satisfies the activity relationship also. Then we draw the network, we put them in a network where we have a flow kind of a thing, and we see which activity is after which activity, and so on and so forth. So then you need to assign these. Say for example, if I'm doing from this activity, I'm doing this activity. So it because and I need to know what is the cost estimate and time taken from going from this activity to this activity, and what this activity, how much time it will take, and what cost it incur. Okay. Then we need to find a critical path. We'll talk about the critical path later, a little bit. What is critical path? We need to find the critical path which will give us a clear indication of the project completion. And we have this network where we have these nodes as activities as nodes, and then there are on the arrows there are the cost and time estimates there, and we can then plan a schedule using the PERT and CPM techniques, right? Then we need to know what is the difference between the PERT and CPM. Basically, PERT is used, when you don't have a clear idea of the cost and maybe the duration. There's uncertainty in activity duration, how much time it will take. We don't know exactly how much time it's going to take. So we have to use some complex estimates to, guess about the time. So that's why it is a probabilistic. So it's a probabilistic model. Okay, probabilistic model, and this one is deterministic. Why? Because we already know the time estimates. Okay, so well-known activity times. Because we have a past experience, we already know how much time it's going to take. So we can build a CP. We can use a CPM if you exactly know the time. But here you don't know the time, so you are guessing, and this is called a probabilistic model, and this is going to be the deterministic model, CPM. And therefore it's applied widely for planning and scheduling research projects, because you are doing the research. You don't know exactly how much it's going to take, so you are going to do the research. Okay, and in this case it's used like for the construction projects and business problems. We already know this. We have to build a house, for example. We already know how much time, because we have built a lot of houses, and we know how much time it is going to take, this project is going to take. Say we have to arrange for bricks, we have to arrange for masons, we have to design and analysis and all of these things. If as a design company, as an architect company, or as an engineer who is working in this company, who exactly knows the stuff, he knows how much time each and every activity is going to take. So we will be using CPM in this. Okay, so in PERT we are doing the research and scheduling. So here we usually do not consider cost, but here it deals with the cost of project scheduling and minimization, right? So if you compare the PERT and CPM, actually both are the quantitative techniques of network analysis. They are used for decision making. Both involve drawing analysis of network diagrams on various cores, right? Your PERT is a probabilistic model, whereas the CPM is a deterministic. Why is it deterministic? Because we already know the time estimates. In probabilistic model, we don't know about the time estimates. And these are non-repetitive jobs like scheduling programs, and here we have repetitive jobs which is already being done. For example, you are doing the construction and you already know the time estimates. Okay, and important thing is it's based on the events. Okay, but here the results are calculated on the basis of activities. Okay, and this is related with the activities of uncertain time, and here we already know well-known time. We already know the time. So overall, what are the advantages of PERT and Cpmr? They reduce the cost. Okay, elimination of risk in complex activity, flexibility, and optimization of resources. That's reduction of uncertainties. And overall, if you have to do the project management, you have to do it in a scientific manner. You cannot just go and start doing some activity and then find out, hey, I have to wait for other activity. And when there is a complex kind of a project, you will end up making a chaos, and the project is never going to finish. So you have to apply scientific techniques, which is the PERT and CPM. So obviously the first step which is going to happen in the PERT or CPM technique is to determination of all specific activities, कि भाई आपके प्रोजेक्ट में क्या क्या एक्टिविटीज हैं, यानी कि आपके प्रोजेक्ट में कौन कौन स्टेप्स हैं, क्या क्या चीज़ें वहाँ पे होती हैं, उनकी रिलेशनशिप आपस में क्या है, वो पता होगी तभी तो हम काम कर सकते हैं. जैसे आप देख लीजिए एग्जाम्पल, ये एक्टिविटीज़ है हमारे प्रोजेक्ट के अंदर. जैसे आपको कुछ जैसे आपको मशीन लानी है और फिर आपको गुड्स बनाने हैं. यू आर मेकिंग अ गुड्स ऑन द मशीन. So you have to first make a budget. So obtain the budget approval. It is, say, its time estimate we know. And it doesn't have a predecessor because इससे पहले कोई काम नहीं होगा, पहला यही काम है, तो इसका predecessor कोई नहीं है. So then B is the obtain the machine. Now if you want to obtain the machine, you will not obtain the machine before budget. So its predecessor is gonna be A. So जब तक कि budget नहीं बनेगा तो machine लाने का तो सवाल ही पैदा नहीं होता. तो उसमें मान लीजिए 5 हफ्ते लगते हैं. So we have the time estimates also. Okay, so then there is a activity C, hire the operator. Then you want to run that machine, you have to hire that operator. Again, अगर आपको बजट नहीं है तो उस ऑपरेटर को सैलरी कौन देगा, तो बजट के हिसाब से ही वो चलेगा. इसलिए this also depends on the A. Right, now install the machine. Now you are trying to install the machine. If there is no machine, how can you install the machine, right? So this has to be dependent on the obtain the machine. In fact, obtain the machine itself depends on obtain the budget, but immediate predecessor we are saying कि इसका immediate predecessor कौन है, वो है obtain the machine. हालांकि खुद ऑब्टेन द मशीन वो डिपेंड है ऑन ए पर, लेकिन ये जो वाली है इंस्टॉल द मशीन दैट इज डिपेंडेंट ऑन द इमीडिएट प्रेडिसेसर, इसका बी है, ठीक है ना। देन ट्रेन द ऑपरेटर, अब जो मशीन चलाएगा उसको ट्रेन करना पड़ेगा, ठीक है ना। अब जो आप ट्रेन करोगे ऑपरेटर को वो कहाँ से करोगे, जब तक कि आपने पहले हायर नहीं किया ऑपरेटर को। सो दैट मीन्स दिस हैज टू डिपेंडेंट ऑन द सी, ठीक है ना। इमीडिएट प्रेडिसेसर इसका ये है, खुद वो ए के ऊपर मुनसर है, एंड सो ऑन। And then you can produce the goods. Now you can produce the goods only when the D has happened, that means you have installed the machine and you have trained the operator. So produce the goods cannot happen if these two together has not happened. अगर install the machine और train the operator दोनों नहीं हुए हैं तब तक आप good नहीं बना सकते। अगर आपके पास machine install है तब भी आप गुड्स नहीं बना सकते क्योंकि ऑपरेटर आपके पास ट्रेन नहीं है, या अगर आपके पास ऑपरेटर ट्रेन है लेकिन मशीन इंस्टॉल नहीं है तो तब भी ये नहीं बन सकता। यानी कि यू हैव टू हैव डी एंड ई बोथ एग्जीक्यूटेड, ओनली देन यू कैन प्रोड्यूस द गुड्स। सो दिस इज our activities and their relationship with each other. This is what we're trying to do in a problem to see the network. In a network, we draw the network diagram after this, that we have the activities and we have the relationship between them and we have the time, duration and all. And then we need the relationship in terms of who is the predecessor, that this is the relationship कि अगर आपको इंस्टॉल करनी है मशीन, ये एक्टिविटी है, वो रिलेट करती हैं पहले इस एक्टिविटी के ऊपर कि आप मशीन को लाएं। अगर आपके पास मशीन लानी है वो करती हैं इस एक्टिविटी पे रिलेट कि आपका बजट उसको अप्रूव करें, ठीक है जी। So what is an activity? It is an effort that's required to complete a part of the project. It's a part of a step of a project, right? And it is represented by the arrows in our network diagram. And node, it is represented by the circle. It represents the beginning or the completion of an activity. Now, there are some rules of the for the network construction, that firstly that we need to have only one arrow between the two activities. There can't be two arrows, okay? So that will be confusing. So there will be only one and only one arrow between the two activities. Second, that if you want to do this activity, its preceding activity must be done. If preceding activity is not done, for example, I'm saying installing the printer, installing the machine, if you have not bought the machine, which machine you will install, so that means the preceding activity should be done, then and only then you can go for the next activity, right? And if you have a bigger arrow or a smaller arrow, it doesn't matter, right? For example, the machine comes here, it gets me a small arrow in the network diagram, you say, hey, this is kind of a small cost or small time. It's not so. The cost and time will be written there with the arrow. The arrow itself is an activity, okay? And these nodes are the beginning and the end of the activity. So there are other rules also here, like the arrow direction. It is, if the arrow is from this to this, that means this is the preceding and this is the next. But if it is like this, that means it's quite simple, right? If there are some activities which end at one particular activity, for example, from this activity and this activity, I cannot make two arrows from the same activity to the same node to same node. So we need to have a separate activities. So these arrows are activities, right? Nodes are the initial and beginning and the end of that activity. So if you have multiple activities ending at one single activity, that means you can have this activity, that means this activity has two preceding activities, so they should be all finished first, then you can go for this activity, right? And then there are the events which are identified by the numbers, okay? Because I told you in the PERT we talk about the events. Now the events can be identified by numbers, and activity by the start and end, because there are 2 points. Activity has start and end, so it needs two numbers or sometimes alphabets. And we need to know that initial and final, they should be the single nodes. It can't be because we have only one initial and terminal nodes. It should not have the multiple initials and multiple terminal nodes, because that will confuse us. So these are our symbols here for the network, to draw the network, so that we can apply the PERT and CPM. Activity is an arrow, event is the circle, okay? The activity A must be completed before activity B. So this is, for example, A and this is B. So if you want to complete the B, then the first A should be, its predecessor should be first done. Now say for example this is A and B and C, they are simultaneously coming up. Say for example we are having the installing the printer and training the operator. Okay. Mm, so they can come simultaneously, not a problem. But when you want to do now the say for example now you want to print, so the both of these things should have happened so that you can start the C. Now as you could see, this is our the sample network. There is a cost and there is an arrow, there's an activity which starts, there's a start point and there's an end point. There's only one single start and single end point. Then there is a cost or time, whatever it is, assigned to the activity, and there is a clear direction that it goes. And you can't have a looping here, you can't go back and forth. Looping is not allowed in the network. Okay. Then there is a clear arrow, who is a predecessor, B is a predecessor, A is a predecessor of B is a predecessor of C, and so on. And you can go to the multiple way to the B, either you go this way or you can go this way. So this is the example of the. There are many things which you need to know, like the dummy activity and all. We will see that by this example. Say for example this is an example where we have these activities and we have the predecessors given and all, and we want to build a network diagram. Okay. So in network diagram we have the arrows. We know we have arrows. That's also called the branch or arc. If you have an arrow in it, right, that is called as a branch or arc. Okay. And beginning and end of the each activity is shown by the node. Okay. And we sometimes use the term event in connection with the node. We can also call them as an event. And this is my node, and then this is the start of the activity, and this is the end of the activity, right? And we need to develop this network diagram for this this set of activities.